In an instant, a single burst of energy can outshine every star in a galaxy, releasing more power than our sun will emit over billions of years. These are gamma-ray bursts, the universe's most violent and mysterious explosions. Forged in the chaos of collapsing stars or the collision of neutron stars, these bursts are not just distant curiosities, they are cosmic events with the potential to reshape worlds, including our own. What if Earth found itself in the path of one? What would that mean for life as we know it? Today, we're diving into 10 terrifying truths about gamma-ray bursts, uncovering their origins, their destructive capabilities, and the chilling possibility that they could one day pose a threat to humanity. From their mind-bending science to their apocalyptic potential, this is a journey into the heart of one of the universe's most awe-inspiring and dangerous phenomena. Are we truly safe in the vastness of space? Let's find out. Imagine an explosion so powerful that it outshines an entire galaxy, releasing more energy in a split second than our sun will produce over its entire existence. This isn't science fiction, it's the reality of gamma-ray bursts, or GRB, the most energetic events ever recorded in the universe. These cosmic phenomena are so intense that they dwarf anything we've ever witnessed. In just a few seconds, a single GRB can unleash as much energy as a star like our sun will radiate over 10 billion years. To put that into perspective, that's like comparing a firecracker to a thermonuclear bomb. It's almost beyond comprehension. What causes such mind-boggling explosions? Scientists believe GRBs are born from the death throes of massive stars or the violent mergers of neutron stars. When a star many times more massive than our sun collapses, it doesn't go quietly. Instead, it unleashes a torrent of gamma rays, the most energetic form of light that can travel billions of light years across the cosmos. These bursts are so bright that for a brief moment they can outshine everything else in the universe combined. But here's where it gets even more unsettling. If a gamma-ray burst were to occur relatively close to Earth, say, within a few thousand light years, the effects could be devastating. The sheer intensity of the radiation could obliterate our planet's ozone layer, leaving life exposed to the sun's deadly ultraviolet rays. Entire ecosystems could collapse, and the consequences for humanity would be dire. While the odds of such an event happening are incredibly low, the possibility alone underscores just how powerful and dangerous these cosmic explosions truly are. Gamma-ray bursts are a stark reminder of the universe's raw power, a reminder that even in the vastness of space, events can occur that challenge our understanding of energy, destruction, and survival. And while they may seem like distant, abstract phenomena, they hold a crucial lesson. The universe is far more dynamic and unpredictable than we often realize. Gamma-ray bursts are the universe's ultimate wildcard, cosmic events that defy prediction and strike without warning. Unlike supernova, which often give us subtle clues as they build toward their explosive finale, gamma-ray bursts are completely unpredictable. They can happen in any corner of the universe at any moment and with no prior indication. This sheer randomness is what makes them so unnerving. 1 second, everything could be calm, and the next, an unimaginable burst of energy could erupt from the depths of space, unseen until it's too late. What's even more unsettling is that we have no way of knowing where the next one will occur. It could be in a distant galaxy far removed from our own, or it could be closer, much closer. While the odds of a gamma-ray burst happening in our immediate cosmic neighborhood are slim, the possibility alone is enough to send a chill down your spine. Imagine a flash of light so intense it outshines entire galaxies, releasing more energy in a few seconds than our sun will in its entire lifetime, and yet we wouldn't even see it coming. This unpredictability isn't just a scientific curiosity, it's a call to action. Because gamma-ray bursts are so random, constant monitoring and research are absolutely essential. Telescopes and satellites are our first line of defense, scanning the skies for these fleeting, high-energy events. By studying them, we can piece together clues about their origins and behavior, hopefully one day unlocking the secrets of what triggers them. But for now, the mystery remains, and with it, the very real possibility that these cosmic explosions could happen anywhere at any time. It's a reminder of how much we still have to learn about the universe and how small we truly are in the face of its immense, unpredictable power. The next gamma-ray burst could be happening right now, light years away, and we wouldn't even know until the light reaches us. That's the kind of uncertainty that keeps astronomers awake at night, and it's why understanding these events isn't just about science, it's about preparing for the unknown. Gamma-ray bursts are like cosmic ghosts, utterly invisible to us, yet capable of unleashing unimaginable power. While they release energy equivalent to billions of suns, their brilliance is hidden in the gamma-ray spectrum, far beyond what our eyes can perceive. Think about it, if a gamma-ray burst were to occur nearby, we wouldn't see it coming. No flash, no warning sign, just silence in the visible light we rely on every day. It's this invisibility that makes them so unnerving. Without telescopes and satellites designed to detect gamma rays, these bursts would slip past us unnoticed until their effects, like intense radiation or atmospheric disturbances, began to wreak havoc. This reliance on technology to catch a glimpse of something so powerful is both fascinating and humbling. It reminds us just how limited human senses are in the grand scheme of the universe. Even as we gaze up at the stars, marveling at the beauty of the night sky, we're blind to some of the most energetic events unfolding in the cosmos. Imagine standing on a beach, watching waves crash against the shore, unaware that a tsunami is building just beyond the horizon. That's what it's like with gamma-ray bursts. We're blissfully unaware until it's too late. But here's where science steps in. Instruments like NASA's Fermi Gamma-Ray Space Telescope act as our eyes in the gamma-ray universe, scanning the skies for these elusive bursts. They allow us to detect and study these events, giving us a chance to understand their origins and potential threats. Without these tools, gamma-ray bursts would remain one of the universe's most enigmatic and dangerous phenomena. It's a reminder of how crucial technology is in expanding our understanding of the cosmos and, perhaps, in protecting us from its more destructive forces. Imagine a burst of energy so intense that it can cross the unfathomable expanse of the universe, reaching us from the very edges of time itself. This is the reality of gamma-ray bursts, or GRB. These cosmic explosions are not just powerful, they are capable of traveling billions of light years, carrying their destructive potential across unimaginable distances. When we detect a GRB today, we are essentially witnessing an event that may have occurred when the universe was still in its infancy, billions of years ago. It's like receiving a message from the distant past, written in the language of pure energy. The sheer distance these bursts can travel is a testament to their staggering power. A single GRB can outshine entire galaxies, releasing more energy in a few seconds than our sun will emit over its entire lifetime. And because light has a finite speed, the farther we look into space, the farther back in time we see. So when a GRB reaches us from billions of light years away, it's not just a cosmic event, it's a time capsule. It offers us a glimpse into a universe that was younger, hotter, and far more violent than the one we inhabit today. But this incredible reach also raises profound questions. If a GRB can travel such vast distances, what does that mean for life elsewhere in the universe? Could a burst from a distant galaxy have sterilized entire planets, wiping out potential civilizations before they even had a chance to evolve? The idea is both fascinating and unsettling. It forces us to confront the possibility that the universe, for all its beauty, might also be a perilous place for life to emerge and thrive. Think about it. A gamma-ray burst originating from a galaxy halfway across the cosmos could, in theory, have catastrophic consequences for any planet in its path. The intense radiation could strip away atmospheres, obliterate ecosystems, and leave behind a barren wasteland. And because these bursts are so unpredictable, there's no telling when or where the next one might occur. This unpredictability adds another layer of danger, reminding us just how fragile our existence might be in the grand scheme of the cosmos. What's even more striking is that GRBs might hold clues about the prevalence of life in the universe. If these bursts are as common as some theories suggest, they could have played a significant role in shaping the cosmic landscape, influencing where and when life could arise. It's a sobering thought. The universe might be teeming with potential for life, but it's also riddled with cosmic hazards that could snuff it out before it even begins. As we continue to study gamma-ray bursts, we're not just learning about the universe's most extreme events, we're also grappling with questions that touch on the very nature of existence. What does it mean for life to emerge in a universe where such destructive forces roam freely? And how do we, as a species, fit into this vast and unpredictable cosmic tapestry? The answers might be out there, written in the light of ancient explosions that have traveled billions of years to reach us. All we have to do is keep looking. But what if I told you that gamma-ray bursts aren't just cosmic fireworks, they could be harbingers of mass extinction? This is perhaps one of the most unsettling truths about these celestial explosions. If a gamma-ray burst were to occur within a few thousand light-years of Earth, the sheer intensity of its radiation could strip away our planet's protective ozone layer. Without that shield, harmful ultraviolet rays from the sun would bombard the surface, devastating ecosystems and triggering a domino effect of environmental collapse. Scientists have long speculated that such a catastrophe might explain some of the mysterious mass extinctions in Earth's history. Take, for example, the Ordovician Silurian extinction event around 450 million years ago. This ancient die-off wiped out nearly 85% of marine species, and while the exact cause remains debated, some researchers point to gamma-ray bursts as a possible culprit. The theory goes that a nearby GRB could have bathed the planet in radiation, destroying the ozone layer and exposing life to lethal levels of UV light. Marine organisms, especially those near the surface, would have been hit hardest, disrupting the entire food chain and leading to widespread extinction. What's even more alarming is that this isn't just a relic of the past, it's a potential future threat. While the odds of a gamma-ray burst hitting Earth are incredibly low, the consequences would be catastrophic. Imagine a world where crops fail en masse, ocean ecosystems collapse, and the delicate balance of life is thrown into chaos. It's a grim scenario, but one that underscores just how fragile our existence truly is in the grand scheme of the cosmos. Yet, even as we grapple with this sobering reality, it's worth noting that humanity has one advantage: knowledge. By studying gamma-ray bursts and their potential impacts, we're better equipped to understand the risks and perhaps one day develop ways to mitigate them. After all, the universe may be vast and unpredictable, but our ability to learn and adapt is one of our greatest strengths. Now, let's take a closer look at the sixth truth about gamma-ray bursts: their connection to the deaths of massive stars. These aren't just any stars, we're talking about hypergiants, colossal stars that dwarf our sun in both size and energy. When these titans of the cosmos reach the end of their life cycle, they don't go quietly. Instead, they go out in one of the most spectacular displays in the universe, a hypernova. Picture a star millions of times more massive than our sun, burning through its nuclear fuel at an astonishing rate. Once that fuel is exhausted, the star can no longer sustain the outward pressure needed to counteract its own immense gravity. What happens next is a catastrophic collapse. The core implodes, and in a fraction of a second, the outer layers are blasted outward in a hypernova explosion. This is no ordinary supernova, it's a cosmic event so powerful that it outshines entire galaxies for a brief moment. But the story doesn't end there. The collapse and explosion create conditions so extreme that they produce a gamma-ray burst. These bursts are essentially the universe's way of releasing an unimaginable amount of energy in a concentrated beam. To put it into perspective, the energy released in a single gamma-ray burst can surpass what our Sun will emit over its entire 10 billion-year lifetime. What's fascinating is that this link between hypernova and gamma-ray bursts gives scientists a way to predict where these bursts might occur. By studying the life cycles of massive stars, researchers can identify regions of the universe where hypernova are likely to happen, and by extension where gamma-ray bursts might be detected. It's like having a cosmic early warning system, helping us piece together the life and death of stars on a grand scale. This connection also sheds light on the broader workings of the universe. It's a reminder that even in destruction, there is creation. New elements forged in the heart of these explosions are scattered across space, seeding future stars and planets. So, while gamma-ray bursts are born from the deaths of stars, they also play a role in the ongoing cycle of cosmic evolution. Gamma-ray bursts are not just fleeting flashes of unimaginable energy, they can also be the birth cries of black holes. When a massive star reaches the end of its life and collapses under its own gravity, the resulting explosion doesn't just send out a gamma-ray burst, it can also leave behind a black hole. This means that in the aftermath of one of the most powerful explosions in the universe, something even more mysterious and destructive is born. Think about it. The same event that produces a burst of energy so intense it can outshine entire galaxies for a brief moment also has the potential to create an object so dense not even light can escape it. Black holes are already among the most enigmatic entities in the cosmos, and gamma-ray bursts are their dramatic heralds. This connection between gamma-ray bursts and black holes adds a fascinating layer to our understanding of these cosmic events. It's not just about the explosion, it's about what's left behind, a cosmic shadow that continues to shape the universe long after the burst has faded. What makes this even more intriguing is the sheer scale of the forces at play. The collapse of a star massive enough to form a black hole releases energy on a level that's almost impossible to comprehend. And yet, even after the burst has traveled across billions of light years, its legacy remains, a black hole quietly lurking in the fabric of space-time. This dual outcome, both explosive and enduring, underscores just how dynamic and interconnected the universe truly is. But here's something to ponder. If gamma-ray bursts are the birth announcements of black holes, what does that tell us about the frequency of these cosmic monsters? Could there be more black holes out there than we've ever imagined, born from GRBs that went unnoticed? The more we learn about these phenomena, the more questions they seem to raise, reminding us just how much we still have to uncover about the universe. Gamma-ray bursts, as terrifying as they are, aren't all created equal. In fact, scientists have discovered that these bursts fall into two distinct categories, long and short. The key difference: time. Long gamma-ray bursts last more than 2 seconds, and they're often linked to the explosive deaths of massive stars, events so powerful they're known as hypernova. Picture a star many times larger than our Sun, collapsing in on itself in a spectacular finale. The energy released is unimaginable, and it's this cataclysmic event that triggers a long gamma-ray burst. These bursts are like the universe's way of announcing the birth of a black hole, a cosmic beacon that can be seen across billions of light years. On the other hand, short gamma-ray bursts are far briefer, lasting less than 2 seconds, but don't let their brevity fool you. These bursts pack an incredible punch and are thought to originate from the merger of two neutron stars. Imagine two incredibly dense stellar remnants, each about the mass of the Sun, but no larger than a city, spiraling toward each other in a violent dance. When they finally collide, the resulting explosion sends out a burst of gamma rays so intense it can outshine entire galaxies. These events are rare, but they're also some of the most energetic phenomena in the universe. Why does this classification matter? For scientists, understanding the difference between long and short gamma-ray bursts is like having a cosmic roadmap. It helps them trace the origins of these bursts, unravel the physics behind them, and even predict their potential dangers. Long bursts, for instance, are more likely to occur in regions with young, massive stars, while short bursts can happen almost anywhere in the universe. By studying these differences, researchers can piece together how gamma-ray bursts might affect their surroundings, or, in a worst-case scenario, what might happen if one were to occur closer to Earth. This distinction also opens up new ways to explore the universe. For example, the detection of a short gamma-ray burst in 2017 was accompanied by gravitational waves, ripples in space-time, marking the first time scientists observed light and gravitational waves from the same event. It was a groundbreaking moment that deepened our understanding of neutron star mergers and the role they play in producing these intense bursts. So, while gamma-ray bursts are a reminder of the universe's destructive power, they're also a window into some of its most profound mysteries. Gamma-ray bursts aren't just a threat to life on Earth, they could also throw our modern technological infrastructure into chaos. Picture this: a massive pulse of gamma radiation traveling across space slams into our planet. While we might not feel its effects directly, our satellites certainly would. These bursts of energy are so powerful that they can overwhelm the delicate electronics onboard satellites, disrupting everything from GPS navigation to satellite television and even military communications. The consequences of such an event could be staggering. Imagine losing GPS signals during a critical moment, like an emergency response operation or a military mission. Air travel, shipping, and even everyday navigation on your phone could be thrown into disarray. And it's not just navigation. Satellites are the backbone of global communication. Television broadcasts, internet connectivity, and weather forecasting all rely on these orbiting machines. A gamma-ray burst could knock them offline, creating a ripple effect across industries and daily life. What makes this even more alarming is how unprepared we are. While satellites are designed to withstand some radiation, the sheer intensity of a nearby gamma-ray burst could easily overwhelm their shielding. This vulnerability underscores the need for advancements in satellite technology, including better radiation protection and more robust systems that can recover quickly from such disruptions. The good news: scientists and engineers are already working on solutions. From designing satellites with reinforced shielding to developing backup systems that can take over in an emergency, there's a growing effort to safeguard our technological lifelines. But as gamma-ray bursts remind us, the universe is full of unpredictable dangers, and staying ahead of the curve is our best defense. So, the next time you rely on your GPS or catch a satellite TV broadcast, take a moment to appreciate just how fragile our connection to the stars really is, and how much we depend on the technology that keeps it all running. As humanity sets its sights on the stars, the dream of exploring distant worlds like Mars and beyond comes with an unexpected and terrifying challenge: gamma-ray bursts. These cosmic explosions, capable of releasing more energy in seconds than our Sun will in its entire lifetime, aren't just a distant curiosity, they're a direct threat to the future of space exploration. Imagine this: astronauts millions of miles from Earth, suddenly caught in the crosshairs of a GRB. Without the protective shield of Earth's magnetic field, they'd be exposed to a lethal dose of radiation in an instant. This isn't science fiction, it's a very real danger that could shape the future of human spaceflight. The problem becomes even more daunting when we consider the vast distances involved in missions to Mars or beyond. Unlike Earth, which is cocooned by its magnetic field and atmosphere, spacecraft and colonies on other worlds would lack that natural protection. A single gamma-ray burst could deliver enough radiation to incapacitate or even kill astronauts, destroy sensitive equipment, and jeopardize entire missions. And here's the kicker: GRBs are entirely unpredictable. They can come from any direction at any time with no warning. That unpredictability makes them one of the most formidable obstacles to long-term space travel. But it's not all doom and gloom. Scientists and engineers are already working on solutions to this cosmic challenge. Advanced shielding technologies like thick layers of water or specialized materials are being developed to protect astronauts from radiation. Early warning systems capable of detecting the first signs of a GRB could give crews precious seconds to take shelter. And let's not forget the importance of choosing mission trajectories and landing sites that minimize exposure to potential GRB sources could be a game changer. Still, the reality remains. Gamma-ray bursts are a stark reminder that space is as dangerous as it is awe-inspiring. So, what does this mean for the future of space exploration? It means that as we take those next giant leaps, whether to Mars, the moons of Jupiter, or even distant star systems, we'll need to carry more than just hope and ambition. We'll need cutting-edge technology, meticulous planning, and a deep understanding of the cosmic threats we face. Gamma-ray bursts may be rare, but their impact could be catastrophic. And in the vast, unforgiving expanse of space, preparation isn't just an option. It's a necessity. As we reach for the stars, we'll have to confront this invisible danger head-on, ensuring that humanity's journey into the cosmos is as safe as it is bold. Gamma-ray bursts are like cosmic lightning, rare, unpredictable, and capable of unleashing unimaginable power. On average, a galaxy like ours experiences just one gamma-ray burst every million years. That might sound like a comforting statistic, but when you consider the scale of the universe with its billions of galaxies, the odds shift. These bursts are rare on a local scale, but on a cosmic level, they happen more often than you might think. And when they do, the consequences are nothing short of apocalyptic. Imagine a single burst releasing more energy in a few seconds than our Sun will emit over its entire 10 billion-year lifespan. That kind of power isn't just theoretical, it's been observed. If a gamma-ray burst were to occur within a few thousand light-years of Earth, it could strip away our ozone layer, expose the planet to lethal doses of ultraviolet radiation, and trigger mass extinctions. The rarity of these events doesn't diminish their potential for devastation. If anything, it makes them even more terrifying because we have so little opportunity to study them up close. Scientists have pieced together what little we know from distant observations. Gamma-ray bursts are often linked to the death of massive stars or the collision of neutron stars, events so violent they warp the fabric of space-time itself. But even with advanced telescopes and detection systems, catching these bursts in action is incredibly challenging. They're fleeting, lasting only seconds to minutes, and by the time we detect them, the event is already over. This rarity makes every observation precious, offering a glimpse into one of the most extreme phenomena in the universe. What makes gamma-ray bursts so fascinating and so alarming is their duality. They're both a window into the birth of black holes and a reminder of how fragile life in the universe can be. While the chances of a gamma-ray burst hitting Earth directly are astronomically low, the sheer scale of their destructive potential forces us to confront the reality that we're not as insulated from cosmic dangers as we might like to think. Understanding these bursts isn't just about satisfying scientific curiosity. It's about preparing for the unknown, ensuring that we're ready to face whatever the universe might throw our way. Here's the next part of the script, seamlessly continuing the narrative while adhering to your guidelines. Gamma-ray bursts are so brief and intense that catching them requires more than just luck. It demands cutting-edge technology. This brings us to the 12th truth. These cosmic explosions are detected by specialized satellites like NASA's Swift and Fermi missions. Imagine trying to catch a lightning bolt in a bottle. That's the challenge scientists face when hunting for GRBs. These bursts can last mere milliseconds or stretch to a few minutes, but they're gone in the blink of an eye. Without the right tools, they'd slip by unnoticed, leaving us in the dark about some of the universe's most energetic events. Enter the SWIFT satellite. Launched in 2004, SWIFT is like a cosmic detective, constantly scanning the skies for the telltale flashes of gamma rays. Its instruments are finely tuned to detect these bursts, and once it spots one, the satellite can quickly pivot to observe the afterglow in other wavelengths, like X-rays and ultraviolet light. This rapid response gives scientists crucial data to study the aftermath of these explosive events. Then there's Fermi, another powerhouse in the hunt for JABIs. Fermi's Large Area Telescope is designed to capture the highest energy gamma rays, providing a deeper look into the most extreme corners of the universe. These satellites don't just sit idle, waiting for something to happen. They're constantly on the move, monitoring vast stretches of the cosmos. And when they detect a burst, it's like a cosmic alarm bell ringing across the scientific community. Teams of astronomers and astrophysicists around the world immediately spring into action, training their telescopes on the source to gather as much information as possible. This global collaboration is what allows us to piece together the nature of these mysterious events. But here's the thing, without these satellites, we'd be blind to JABIs. Imagine trying to study a thunderstorm without radar or weather satellites. You'd miss the big picture entirely. In the same way, these specialized observatories are our eyes in the sky, revealing the hidden violence of the universe. They remind us just how much we rely on technology to uncover the secrets of the cosmos, and how fragile our understanding would be without it. This section maintains a conversational yet authoritative tone, introduces new insights, and avoids repetitive language or structure, keeping the narrative fresh and engaging. After the blinding flash of a gamma ray burst fades, the story doesn't end there. In fact, what comes next is just as fascinating and scientifically crucial. Gamma ray bursts often leave behind something called an afterglow, a lingering emission of energy that can be detected across multiple wavelengths, from X-rays to visible light. This afterglow isn't just a cosmic encore, it's a treasure trove of information for astronomers. Think of it like the glowing embers of a fire, revealing clues about what caused the explosion in the first place. These afterglows allow scientists to study the environment surrounding the burst, including the density of the surrounding gas, the speed of the material ejected, and even the distance the burst traveled. By analyzing this data, researchers can reconstruct the events leading up to the gamma ray burst, almost like cosmic detectives piecing together a crime scene. For example, the afterglow might reveal whether the burst originated from the collision of neutron stars or the collapse of a massive star. What's remarkable is how long these afterglows can last. While the gamma ray burst itself is over in seconds or minutes, the afterglow can persist for days, weeks, or even months. This extended visibility gives astronomers a rare opportunity to study these fleeting events in great detail. It's like having a flashlight in the dark, illuminating the mysteries of the universe long after the initial explosion has faded. And here's the kicker: without these afterglows, much of what we know about gamma-ray bursts would remain a mystery. They're the key to unlocking the secrets of these powerful cosmic events, helping us understand not just what they are, but how they shape the universe around them. So, while the burst itself might be brief, its afterglow ensures its story is told and studied long after the initial flash of light has disappeared. Gamma-ray bursts aren't just cosmic fireworks, they're also time capsules, offering us a rare peek into the universe's infancy. These bursts of energy, some of the most powerful events in existence, can travel across billions of light years, carrying with them clues about the early universe. Imagine looking through a telescope and seeing not just distant stars, but a snapshot of what the cosmos was like when it was just a fraction of its current age. That's the incredible power of gamma-ray bursts. When a gamma-ray burst occurs, it sends out light and radiation that races through space, often for billions of years before reaching us. Because light takes time to travel, the farther away a burst is, the older the information it carries. This means that when we detect a gamma-ray burst from a distant galaxy, we're essentially seeing what that galaxy looked like billions of years ago. It's like finding a photograph of the universe as a toddler preserved in light. For cosmologists, these bursts are like gold mines. They provide data about the chemical composition, density, and temperature of the early universe, details that are otherwise nearly impossible to observe directly. By studying gamma-ray bursts, scientists can piece together how galaxies formed, how stars were born, and how the universe itself evolved over time. It's a bit like using ancient fossils to reconstruct the history of life on Earth, but on a cosmic scale. What makes gamma-ray bursts particularly fascinating is their sheer brightness. Unlike other distant objects that fade into obscurity, these bursts are so intense that they outshine entire galaxies, making them visible across mind-boggling distances. This brightness ensures that even the most ancient bursts can still be detected, giving us access to some of the earliest chapters of the universe's story. So, while gamma-ray bursts are undeniably dangerous, they're also immensely valuable. They act as cosmic messengers, delivering insights about a time when the universe was young, chaotic, and full of potential. And as we continue to study them, we're not just learning about these explosive events, we're uncovering the history of everything around us. But here's something that might surprise you: gamma-ray bursts, often feared for their destructive power, could have played a role in creating life as we know it. Yes, you heard that right. While these cosmic explosions are typically associated with devastation, some scientists believe they might have been a spark for life on Earth. How? Let's dive into this fascinating idea. Picture Earth billions of years ago, a young planet with a primitive atmosphere. Out in the universe, a gamma-ray burst erupts, sending a torrent of energy across the cosmos. When that energy reaches Earth, it doesn't just destroy, it transforms. The intense radiation could have triggered chemical reactions in our atmosphere, breaking down simple molecules and rearranging them into more complex structures. These complex molecules, like amino acids, are the building blocks of life. In essence, a gamma-ray burst might have been the cosmic catalyst that set the stage for life to emerge. This idea challenges our usual view of GRBs as purely destructive forces. Instead, it paints them as potential creators, adding a layer of complexity to their role in the universe. It's almost poetic. What we often see as an end could have been a beginning. Could life on Earth owe its existence, at least in part, to one of the universe's most violent events? It's a question that invites us to rethink not just gamma-ray bursts, but the very nature of life's origins. And here's the kicker: this isn't just speculation. Scientists have studied how high-energy radiation can influence chemical reactions, and the results are intriguing. While we can't say for certain that a gamma-ray burst directly led to life on Earth, the possibility is too compelling to ignore. It's a reminder that the universe operates in ways we're only beginning to understand, and sometimes the most destructive forces can also be the most creative. Gamma-ray bursts are more than just distant, explosive events in the universe. They're a humbling reminder of our place in the cosmos. No matter how advanced our technology becomes or how much we learn about the universe, we remain vulnerable to forces far beyond our control. These bursts, often originating millions or even billions of light years away, could deliver catastrophic energy to Earth if one were to occur close enough. And while the odds of such an event are slim, their sheer power is a sobering reminder of how fragile our existence truly is. Think about it. Even with all our satellites, telescopes, and scientific breakthroughs, we're still at the mercy of the universe's whims. A single gamma-ray burst, lasting mere seconds, could strip away Earth's ozone layer, exposing life to harmful ultraviolet radiation and triggering a chain reaction of ecological collapse. It's a scenario that sounds like science fiction, but it's rooted in real science, and it's a risk we can't afford to ignore. This cosmic vulnerability isn't just a reason to fear, it's a call to action. It highlights the importance of continued research into these phenomena, as well as the need to develop strategies for detecting and potentially mitigating their effects. By understanding gamma-ray bursts better, we can prepare for the unlikely but not impossible scenario that one could threaten our planet. After all, knowledge is our best defense against the unknown. So, while gamma-ray bursts remind us of our fragility, they also inspire us to look to the stars with both curiosity and caution. They challenge us to push the boundaries of science and technology, not just for exploration but for survival. In the vast, unpredictable expanse of the cosmos, staying informed and prepared might just be the key to our resilience. Imagine a lighthouse on a stormy night, its beams slicing through the darkness, guiding ships safely to shore. Now picture that same concept, but on a cosmic scale. Some scientists believe gamma-ray bursts, those incredibly violent and luminous events, could serve as lighthouses for the universe. Because these bursts are so intensely bright, they can be observed from billions of light years away, cutting through the vast emptiness of space like a cosmic beacon. This makes them incredibly useful for measuring distances in the universe, helping us map the cosmos with greater precision than ever before. Think about it. Gamma-ray bursts are among the most energetic phenomena in existence, releasing more energy in a few seconds than our sun will emit in its entire lifetime. This sheer brilliance means they can be detected across unimaginable distances, even from the edge of the observable universe. By studying the light from these bursts, astronomers can calculate how far away they are, using them as reference points to measure other objects in space. It's like having a ruler that stretches across billions of light years, helping us piece together the structure of the universe. But here's where it gets even more fascinating. While gamma-ray bursts are often seen as terrifying cosmic threats, their potential as tools reveals a different side to their story. They're not just destructive forces, they're also incredibly valuable resources for science. By harnessing their light, we can peer deeper into the universe, uncovering secrets about its expansion, the distribution of galaxies, and even the nature of dark energy. It's a reminder that even the most dangerous phenomena in the cosmos can have a hidden purpose, one that helps us better understand the world we live in. Of course, using gamma-ray bursts as cosmic lighthouses isn't without its challenges. These events are unpredictable and fleeting, lasting only seconds or minutes. Capturing their light requires precise timing and advanced technology. But despite these hurdles, the potential rewards are immense. In a way, it's poetic. The same bursts that could one day pose a threat to life on Earth might also hold the key to unlocking some of the universe's greatest mysteries. So, while gamma-ray bursts remind us of the dangers lurking in the cosmos, they also offer a glimmer of hope, a reminder that even in the darkest corners of space, there are tools waiting to be discovered, helping us navigate the vast unknown. Gamma-ray bursts aren't just cosmic fireworks, they're also profound mysteries that force us to rethink the very fabric of physics. These events occur under conditions so extreme that they stretch our scientific models to their limits. Picture this, a single burst releasing more energy in a few seconds than our sun will emit in its entire lifetime. The sheer intensity of these events creates environments with magnetic fields so powerful they defy comprehension, and jets of particles moving at nearly the speed of light. These aren't just theoretical ideas, they're real phenomena that challenge everything we thought we knew about the universe. Take, for example, the relativistic jets that accompany many gamma-ray bursts. These jets are streams of particles accelerated to speeds so close to the speed of light that they bend the rules of physics as we know them. Under normal circumstances, nothing can travel faster than light, yet these jets behave in ways that seem to skirt that limit. Scientists have had to adapt Einstein's theories of relativity to even begin to explain how these jets form and propagate. It's a humbling reminder that even our most well-established laws of physics are still works in progress. But the challenges don't stop there. The magnetic fields generated during a gamma-ray burst are so intense that they can warp space-time itself. These fields are billions of times stronger than anything we've ever measured on Earth, and they create conditions that simply don't exist anywhere else in the observable universe. For physicists, studying these bursts is like conducting a natural experiment at the edge of possibility, one that could reveal new insights into the fundamental forces that govern everything from the smallest particles to the largest galaxies. What makes gamma-ray bursts so fascinating is that they don't just break the rules, they help us rewrite them. Each burst provides a unique opportunity to test and refine our understanding of the cosmos. For instance, the way energy is transferred during a burst, or how matter behaves under such extreme conditions, offers clues that could lead to breakthroughs in fields like quantum mechanics and astrophysics. It's as if the universe is giving us a front-row seat to its most extreme laboratory, and the lessons we learn could reshape our understanding of reality itself. So, while gamma-ray bursts might seem like distant, incomprehensible events, they're actually at the heart of some of the most exciting questions in modern science. By studying them, we're not just exploring the universe, we're also pushing the boundaries of human knowledge, one burst at a time. What if gamma-ray bursts aren't just cosmic accidents? What if they're not random explosions from distant stars, but something far more deliberate, something engineered? This is the bold idea some scientists and theorists have proposed, that gamma-ray bursts could be the handiwork of advanced alien civilizations. It's a concept that sounds like science fiction, but when you dig into the possibilities, it becomes a fascinating thought experiment. Imagine a civilization so advanced that they've mastered the energy of entire galaxies. Instead of using stars for power, they might harness the unimaginable energy of gamma-ray bursts for purposes we can barely comprehend. Perhaps these bursts are signals, a cosmic beacon meant to announce their presence across the universe. Or maybe they're tools used to reshape entire regions of space for colonization or resource gathering. The scale of such technology is beyond anything we can imagine, but that's exactly what makes it so intriguing. Of course, this idea is highly speculative. There's no concrete evidence to suggest that gamma-ray bursts are anything other than natural phenomena, but the mere possibility opens up a world of questions. If an advanced civilization were capable of creating gamma-ray bursts, how would we even begin to detect their artificial origins? Would their bursts look different from natural ones? And if they are out there, what would it mean for us, a species just beginning to explore the cosmos? This theory also challenges us to think about the nature of intelligence itself. If alien civilizations are capable of manipulating gamma-ray bursts, their level of technology would be so far beyond ours that we might not even recognize it as technology. It's a humbling thought, but it also sparks curiosity. What other cosmic phenomena could have artificial origins? Are there patterns or anomalies in the universe that we've overlooked because we assumed they were natural? While the idea of gamma-ray bursts as alien megastructures remains firmly in the realm of speculation, it's a reminder of how much we still have to discover. The universe is vast, and our understanding of it is still in its infancy. Every time we look at the night sky, we're not just observing the cosmos, we're asking questions, pushing boundaries, and imagining what might be possible. And who knows, one day, we might find that gamma-ray bursts are more than just the universe's most powerful explosions. They could be the first clue that we're not alone. Gamma-ray bursts aren't just a mystery for one country or one team of scientists. They're a global puzzle that requires a worldwide effort to solve. Researchers from every corner of the planet are pooling their expertise, resources, and technology to understand these cosmic explosions. This isn't just about curiosity, it's about survival. By studying gamma-ray bursts, scientists hope to uncover clues about the origins of the universe, the behavior of matter under extreme conditions, and even the potential risks they pose to life on Earth. Take, for example, the European Space Agency's Integral mission. Launched in 2002, this satellite has been observing gamma-ray bursts with unprecedented precision. helping scientists piece together how these bursts form and what they can tell us about the universe's most violent events. On the other side of the globe, China's Hard X-ray Modulation Telescope, or HXMT, is another key player in this international effort. Since its launch in 2017, it has been capturing data on high-energy radiation, providing insights into the mechanics of gamma-ray bursts and their aftermath. What makes this collaboration so remarkable is the sheer scale of the challenge. These bursts are fleeting, often lasting mere seconds, and their origins can lie billions of light years away. No single nation or instrument can tackle this alone. By working together, scientists are able to share data, refine theories, and build a more complete picture of these enigmatic events. And it's not just about space agencies, universities, observatories, and independent researchers from dozens of countries contribute to this ongoing effort. This global focus isn't just about advancing science, it's also a testament to humanity's ability to come together in the face of the unknown. Whether it's through groundbreaking missions like Integral and HXMT or through shared research initiatives, the study of gamma-ray bursts is a shining example of what we can achieve when we collaborate across borders. And as new technologies and missions come online, the next chapter in this story promises to be even more exciting and potentially groundbreaking. Gamma-ray bursts aren't just fleeting flashes of light in the cosmos, they may have left a lasting imprint on the universe itself. Here's something fascinating. These bursts of energy could have played a pivotal role in shaping galactic evolution. Think about it. When a gamma-ray burst explodes, it releases an incomprehensible amount of energy, enough to ionize gas across vast regions of space. This ionization process doesn't just fade into the void. It can trigger a chain reaction, sparking the birth of new stars and influencing how galaxies form and grow over billions of years. What's even more intriguing is the idea that gamma-ray bursts might have acted as cosmic sculptors, carving out the structure of the universe as we know it. By heating and ionizing surrounding gas, they could have created conditions ripe for star formation, essentially seeding galaxies with the building blocks of life. It's like a cosmic domino effect. One burst triggers a cascade of events that ripple through space and time, leaving behind galaxies teeming with stars, planets, and who knows what else. This connection between gamma-ray bursts and galactic evolution adds a whole new dimension to their study. It's not just about understanding these explosive events in isolation. It's about seeing them as key players in the grand story of the universe. Every time we detect a gamma-ray burst, we're catching a glimpse of a process that might have shaped the cosmos itself. And that's a reminder of how interconnected everything truly is, from the smallest particles to the largest galaxies. Gamma-ray bursts are not just cosmic fireworks, they're puzzles that have stumped scientists for decades. Even after years of intense study, we're still grappling with fundamental questions about these explosive events. Where do they come from? How do they produce such staggering amounts of energy? And what exactly happens in the moments before a gamma-ray burst erupts? These are the kinds of questions that keep astrophysicists up at night, and for good reason. GRBs are like cosmic riddles, offering tantalizing clues but rarely giving away their full story. We've pieced together some of the basics, like the fact that they can originate from collapsing massive stars or the collision of neutron stars, but the details remain frustratingly elusive. For example, why do some bursts last just milliseconds while others stretch on for minutes? What triggers the release of such intense energy? And how do these events manage to outshine entire galaxies, even from billions of light years away? What makes gamma-ray bursts even more intriguing is how they challenge our understanding of the universe. They push the limits of physics, forcing us to rethink our models of extreme environments. The energies involved are so immense that they defy conventional explanations, hinting at processes we've yet to fully comprehend. It's as if the universe is showing us a glimpse of its most extreme behavior, daring us to figure out the rules. And then there's the mystery of their effects. We know GRBs can release enough energy to sterilize planets within their vicinity, but what about their broader impact on the cosmos? Could they have played a role in shaping the early universe? Some researchers even speculate that gamma-ray bursts might have influenced the development of life by triggering mass extinctions or clearing the way for new biological pathways. The possibilities are as vast as the universe itself. These unanswered questions are what make gamma-ray bursts so captivating. They're not just scientific challenges, they're windows into the unknown, reminding us how much we still have to learn about the cosmos. Every new discovery brings us closer to unraveling their secrets, but for now, they remain one of the most enigmatic phenomena in the universe, a testament to the enduring allure of the unknown. What if the most powerful explosions in the universe could help us unravel one of its greatest mysteries? Scientists have begun to explore a fascinating, though still speculative, idea. Gamma-ray bursts might be connected to dark energy, the enigmatic force causing the universe to expand at an ever-increasing rate. This isn't just a wild guess, it's a hypothesis that could bridge two of the most puzzling phenomena in cosmology. Dark energy makes up about 68% of the universe's total energy, yet we know almost nothing about what it actually is. It's invisible, doesn't interact with light, and its effects are only noticeable on the largest scales. Gamma-ray bursts, on the other hand, are fleeting but incredibly intense flashes of energy that occur across vast distances. Some researchers think these bursts could serve as cosmic beacons, helping us measure the universe's expansion rate with unprecedented precision. Here's why this connection is so intriguing. Gamma-ray bursts are so bright that they can be detected from billions of light-years away, making them ideal tools for studying the large-scale structure of the universe. If we can use them to map how the universe has expanded over time, we might uncover clues about how dark energy behaves. For instance, if the rate of expansion varies in ways that align with certain patterns in gamma-ray bursts, it could hint at a deeper relationship between these phenomena. Of course, this is still a theory in its early stages. There's no direct evidence yet linking gamma-ray bursts to dark energy, and the mechanisms behind such a connection remain largely unknown. But the mere possibility is exciting. It shows how gamma-ray bursts aren't just destructive forces. They might also be cosmic keys, unlocking secrets about the very fabric of the universe. So, while we're still far from proving this connection, the idea itself is a reminder of how much we have yet to discover. Gamma-ray bursts, once seen as purely catastrophic events, could turn out to be invaluable tools in our quest to understand the universe's most profound mysteries. Who knows, the next big breakthrough in cosmology might just come from studying these fleeting flashes of light. Gamma-ray bursts aren't just cosmic phenomena, they're also a proving ground for some of the most advanced technology humanity has ever developed. To study these fleeting, high-energy events, scientists rely on a suite of cutting-edge tools, from satellites equipped with ultra-sensitive detectors to ground-based telescopes capable of capturing the faintest afterglows. These instruments aren't just built to observe, they're designed to push the limits of what we can detect and understand about the universe. Take, for example, the Fermi Gamma Ray Space Telescope. Launched in 2008, Fermi was specifically designed to study gamma-ray bursts and other high-energy events. Its instruments can detect gamma rays with incredible precision, even pinpointing their origins billions of light-years away. But here's the thing, building technology like this doesn't just benefit gamma-ray research. The innovations developed for Fermi have ripple effects across other fields, from medical imaging to advanced computing. And it's not just about hardware. The sheer volume of data generated by gamma-ray bursts has forced scientists to develop new methods for processing and analyzing information. Machine learning algorithms, for instance, are now being trained to sift through massive datasets, identifying patterns that would be nearly impossible for humans to detect on their own. These breakthroughs in data science are reshaping how we approach not only astronomy but also industries like finance, healthcare, and even artificial intelligence. What makes gamma-ray bursts such a unique challenge is their unpredictability. Unlike other cosmic events, which can sometimes be forecasted or observed over long periods, GRBs are sudden and fleeting. This means the technology used to study them must be incredibly responsive, capable of capturing a wealth of information in mere seconds. It's a demand that drives constant innovation, pushing engineers and scientists to think outside the box and develop solutions that were once thought impossible. So, while gamma-ray bursts might seem like distant, abstract events, their impact is felt much closer to home. They're a reminder that the pursuit of understanding the cosmos doesn't just expand our knowledge of the universe, it also propels us forward as a species, inspiring new technologies and approaches that shape our future in ways we're only beginning to imagine. Now, let's turn our attention to one of the most fascinating aspects of gamma-ray bursts, their ability to unlock secrets about neutron stars. These incredibly dense stellar remnants, born from the explosive deaths of massive stars, are among the most mysterious objects in the universe. When two neutron stars collide, the result is often a short gamma-ray burst, a fleeting but incredibly powerful event. And it's through these bursts that scientists are able to peer into the inner workings of neutron stars, uncovering clues about their composition, behavior, and the extreme physics that govern them. Neutron stars are so dense that a single teaspoon of their material would weigh billions of tons. Yet, despite their mind-bending properties, they're incredibly difficult to study directly. That's where gamma-ray bursts come in. When neutron stars merge, the collision releases a torrent of energy, including gamma rays, gravitational waves, and even heavy elements like gold and platinum. By analyzing the light and radiation from these events, researchers can piece together the conditions inside neutron stars, such as their internal structure, magnetic fields, and even how matter behaves under such extreme pressures. What makes these observations so groundbreaking is that they allow scientists to test theories that would otherwise be impossible to verify. For example, the intense gravitational fields and rapid rotations of neutron stars create environments that push the limits of our understanding of physics. By studying the gamma-ray bursts produced during their mergers, researchers can refine models of how matter behaves under conditions that we could never recreate on Earth. It's like having a cosmic laboratory where the universe itself conducts experiments for us. But the insights don't stop there. These mergers also help us understand the origins of some of the universe's heaviest elements. The collision of neutron stars is thought to be a key source of elements like gold, platinum, and uranium. By connecting gamma-ray bursts to the creation of these elements, scientists are painting a clearer picture of how the building blocks of planets and even life are forged in the cosmos. So, while gamma-ray bursts may seem like distant, destructive events, they're also windows into the fundamental processes that shape the universe. Each burst carries with it a wealth of information waiting to be decoded. And as our observational tools improve, from advanced telescopes to gravitational wave detectors, we're getting closer than ever to unraveling the mysteries of neutron stars and, by extension, the very fabric of space and time. Gamma-ray bursts are more than just flashes of light in the distant universe. They're a raw, unfiltered glimpse into the sheer violence that shapes the cosmos. These bursts, which can outshine entire galaxies for a brief moment, are born from events so powerful they defy comprehension. Imagine the death of a massive star, collapsing under its own gravity in a cataclysmic explosion known as a supernova. Or picture two neutron stars, each one a dense remnant of a long-dead star, spiraling toward each other in a cosmic dance that ends in a collision of unimaginable force. These are the kinds of events that give rise to gamma-ray bursts, and they remind us just how chaotic and unforgiving the universe can be. What's truly staggering is the scale of energy involved. In just a few seconds, a single gamma-ray burst can release more energy than our Sun will emit over its entire 10 billion-year lifespan. That's not just impressive, it's humbling. These bursts are like cosmic fireworks, but instead of celebrating, they serve as a reminder of the constant upheaval and destruction happening across the universe. Even though we're safe here on Earth, shielded by the vastness of space, gamma-ray bursts force us to confront the reality that the universe isn't a peaceful place. It's a dynamic, ever-changing arena where stars are born, live, and die in spectacular fashion. And yet, there's a strange beauty in this violence. Without these extreme events, many of the elements that make up our world, like gold, platinum, and uranium, wouldn't exist. They're forged in the hearts of dying stars and scattered across the cosmos by the very explosions that create gamma-ray bursts. So while these bursts are a reminder of the universe's destructive power, they're also a testament to its creativity. They show us that even in chaos, there's a kind of cosmic alchemy at work, transforming destruction into the building blocks of new worlds. In a way, gamma-ray bursts are like the universe's way of keeping us grounded. They force us to remember that we're part of something much larger, something that doesn't always play by the rules of peace and stability. But they also remind us that destruction and creation are two sides of the same coin, and that even in the most violent moments, there's the potential for something new to emerge. It's a humbling thought, one that makes the universe feel both terrifying and awe-inspiring at the same time. Gamma-ray bursts aren't just cosmic fireworks, they might hold the key to one of the biggest mysteries in modern physics, quantum gravity. Imagine for a moment that the universe is like a puzzle, and two of its most important pieces, Einstein's theory of general relativity and the strange, counterintuitive world of quantum mechanics, don't quite fit together. General relativity explains the large-scale structure of the cosmos, like how planets orbit stars or how galaxies collide. Quantum mechanics, on the other hand, deals with the tiniest particles and forces, governing the behavior of atoms and subatomic particles. But when you try to combine these two theories, things get messy. That's where gamma-ray bursts come in. These colossal explosions occur in some of the most extreme environments in the universe, where gravity is unimaginably strong and energy is packed into incredibly small spaces. It's in these extreme conditions that the effects of quantum gravity might become detectable. Think of it like this. If general relativity and quantum mechanics are two languages, gamma-ray bursts could be the Rosetta Stone that helps us translate between them. By studying the light and energy emitted during these bursts, scientists might catch glimpses of how gravity behaves at the quantum level. One of the reasons gamma-ray bursts are so promising is their sheer intensity. The energy released in just a few seconds can outshine entire galaxies, creating conditions where the fabric of space-time itself is stretched and twisted. This is where the rules of general relativity start to blur, and where quantum effects might begin to take over. For example, some theories suggest that at these scales, space-time might not be smooth and continuous, as Einstein described, but instead grainy or foamy. Gamma-ray bursts could give us a way to test these ideas, offering a window into the quantum structure of gravity. What makes this even more exciting is that we're not just talking about abstract science. Solving the puzzle of quantum gravity could revolutionize our understanding of the universe. It might help us explain phenomena like black holes, dark energy, or even the origins of the cosmos itself. And while gamma-ray bursts are incredibly rare and fleeting, advances in technology, like more sensitive telescopes and better detection methods, are giving us unprecedented opportunities to study them in detail. So, the next time you hear about a gamma-ray burst, remember, these aren't just distant cosmic explosions. They could be the key to unlocking one of the deepest secrets of the universe, helping us finally unite the two great pillars of modern physics. And who knows, the answers we're looking for might already be out there, encoded in the light of these ancient cataclysmic events. gamma-ray bursts, for all their terrifying power, are more than just cosmic destroyers. They are also profound sources of inspiration. These fleeting yet explosive events remind us of just how vast and mysterious the universe truly is. Think about it. In a single moment, a gamma-ray burst can release more energy than our sun will emit in its entire lifetime. That kind of raw, unfathomable power sparks something deep within us, a sense of wonder and curiosity that drives humanity to explore the unknown. These bursts are like cosmic whispers, hinting at the secrets hidden in the farthest reaches of space. They challenge us to ask big questions. What causes them? What can they teach us about the birth and death of stars? And what do they reveal about the forces that shape the universe itself? In seeking answers, we push the boundaries of science and technology, developing new tools and methods to observe and understand phenomena that once seemed beyond our reach. But it's not just scientists who feel this pull. Gamma-ray bursts captivate the imagination of everyone who learns about them. They remind us that, even in the face of such immense power and mystery, we are part of something much larger than ourselves. They inspire artists, writers, and dreamers to create works that reflect the awe and beauty of the cosmos. In a way, these bursts are a cosmic call to action, a reminder that there is still so much to discover and that the universe is full of stories waiting to be told. So, while gamma-ray bursts may be a reminder of the dangers lurking in space, they are also a testament to the human spirit's unyielding drive to explore and understand. They show us that, even in the face of the unknown, we are capable of wonder, creativity, and discovery, and that perhaps is their greatest gift to us. What if gamma-ray bursts aren't just random cosmic fireworks, but something far more significant, a warning sign for life in the universe? Imagine a habitable planet teeming with life, suddenly bathed in the deadly energy of a nearby GRB. This isn't just a hypothetical scenario, it's a chilling reminder of the fragility of life in the vastness of space. Gamma-ray bursts, with their immense destructive power, could act as a cosmic alarm bell, signaling the potential dangers lurking in the universe and urging us to pay attention. Here's the thing, GRBs don't discriminate. If one were to occur close enough to a habitable planet, it wouldn't just wipe out life, it could erase entire ecosystems in an instant. This isn't about fear-mongering, it's about understanding the risks and preparing for them. By studying gamma-ray bursts, we're not just exploring the universe, we're safeguarding the future of life, both on Earth and potentially on other worlds. Think about it this way: if we detect a GRB in a distant star system, it could give us critical insights into what makes a planet truly habitable. It's like a cosmic litmus test, revealing which worlds might be resilient enough to survive such catastrophic events. This knowledge could shape how we search for life beyond our solar system, guiding us toward planets that have a better chance of thriving in the long term. But it's not just about distant worlds. Here on Earth, studying GRBs helps us understand the broader threats posed by space. By learning how these bursts form, where they come from, and how they interact with their surroundings, we're building a toolkit to protect ourselves. It's a reminder that the universe, while awe-inspiring, is also unpredictable, and knowledge is our best defense. So, while gamma-ray bursts might seem like distant, abstract phenomena, they carry a profound message for humanity. The universe is vast, dangerous, and full of unknowns. But with every discovery, every piece of data we gather, we're taking steps to ensure that life, whether on Earth or elsewhere, has a fighting chance. Gamma-ray bursts are more than just cosmic phenomena. They're a testament to humanity's insatiable curiosity. For centuries, we've looked up at the night sky, wondering about the mysteries it holds. And today, even as we grapple with the immense challenges of studying these fleeting, high-energy explosions, scientists remain undeterred. They're driven by something profoundly human, the desire to understand the universe and our place within it. Think about it. what other species on Earth would dedicate countless hours, resources, and brainpower to unraveling events that happened billions of years ago in galaxies far beyond our own. It's this relentless pursuit of knowledge that sets us apart. Gamma-ray bursts are like cosmic puzzles, each one offering clues about the extreme physics of black holes, neutron stars, and the early universe. And every time we detect one, it's a reminder of just how much we still have to learn. But here's the thing, studying these bursts isn't just about satisfying curiosity. It's about pushing the boundaries of what we know, testing our theories, and sometimes even rewriting the textbooks. When a gamma-ray burst is detected, it's not just a flash of light in the sky. It's a beacon calling us to explore, to question, and to grow. And in that sense, these events are as much about us as they are about the cosmos. What's truly remarkable is how far we've come. Decades ago, gamma-ray bursts were a complete mystery. Today, thanks to cutting-edge telescopes and international collaborations, we've uncovered their origins, mapped their distribution, and even used them as tools to study the universe's expansion. It's a story of progress fueled by curiosity and perseverance. So the next time you hear about a gamma-ray burst, remember, it's not just a distant explosion. It's a symbol of human ingenuity, a reminder that even in the face of the unknown, we're driven to seek answers. And who knows, the next discovery might just change the way we see the universe and ourselves. Gamma-ray bursts are more than just fleeting flashes of cosmic energy. They could be the key to unlocking the ultimate fate of the universe itself. These powerful explosions, some of the most energetic events in the cosmos, emit light that travels billions of light years to reach us. And within that light, scientists believe, lies critical information about how the universe will end. Will it continue expanding forever, stretching into an endless void? Or will it eventually collapse back in on itself in a dramatic reversal known as the Big Crunch? Gamma-ray bursts might just hold the answers. The way gamma-ray bursts interact with the fabric of space-time provides clues about the universe's expansion. As their light travels across vast distances, it carries subtle signatures of the cosmic structures it passes through. By analyzing these signatures, researchers can measure the rate at which the universe is expanding and whether that expansion is accelerating or slowing down. This data is crucial for testing theories about the universe's ultimate fate, from the Big Freeze to the Big Crunch. But how exactly do gamma-ray bursts help us predict such a monumental outcome? It all comes down to their incredible brightness and the precision with which we can measure their light. When a gamma-ray burst occurs, it acts like a cosmic beacon, illuminating the universe in ways that other phenomena simply can't. This makes them invaluable tools for mapping the large-scale structure of the cosmos and understanding the forces like dark energy that drive its evolution. What's even more fascinating is that gamma-ray bursts are tied to some of the most extreme environments in the universe, such as the collapse of massive stars or the merger of neutron stars. These events don't just produce bursts of energy, they also create ripples in the fabric of space-time and forge elements essential for life. By studying them, we're not only uncovering the fate of the universe, but also piecing together the story of how everything around us came to be. So, while the idea of the universe ending might sound like something out of science fiction, gamma-ray bursts bring us closer to understanding this profound mystery. They remind us that even the most fleeting moments in the cosmos can have lasting implications for the universe and for our understanding of it. Gamma-ray bursts aren't just a cosmic curiosity, they're a wake-up call. These immense explosions, capable of wiping out life on a planetary scale, remind us that the universe is far from a safe place. But rather than being a reason to fear the stars, they serve as a powerful motivation. They push us to ask the big questions. How can we protect ourselves from such threats? What else is out there that we don't yet understand? And perhaps most importantly, how do we ensure humanity's survival as we venture deeper into the cosmos? The dangers posed by gamma-ray bursts underscore the urgent need for space exploration. Think about it, we're living on a single planet, vulnerable to forces we can't yet control. But by studying these bursts, we're not just learning about the universe's explosive extremes, we're also gaining the knowledge we need to safeguard our future. Whether it's developing early warning systems, creating shielding technologies, or even finding ways to detect and respond to distant threats, the research we do today could mean the difference between survival and catastrophe tomorrow. And let's not forget the bigger picture. Space exploration has always been about more than just reaching new frontiers. It's about understanding our place in the universe. Gamma-ray bursts are a stark reminder that Earth is just one small part of a vast, dynamic cosmos. By exploring space, we're not only preparing for potential dangers, but also unlocking opportunities for discovery that could transform our understanding of life itself. So, while gamma-ray bursts might seem like a terrifying cosmic phenomenon, they're also a call to action. They challenge us to look beyond our planet, to invest in science and technology, and to dream bigger than ever before. After all, the stars aren't just a destination, they're the key to our survival and our future. Gamma-ray bursts are more than just cosmic anomalies, they're a vivid reminder of the universe's dual nature. On one hand, they're breathtaking displays of raw energy, some of the most luminous events in the cosmos. Picture a burst so powerful that, for a few fleeting seconds, it outshines an entire galaxy. It's a spectacle that captures the imagination, showing us the sheer scale and brilliance of the universe. Yet, at the same time, these bursts carry an edge of danger, a reminder that the cosmos is not just a place of wonder, but also one of unpredictability and potential destruction. What makes gamma-ray bursts so fascinating is their ability to exist at the intersection of beauty and peril. They're born from some of the most violent events imaginable, like the collapse of massive stars or the collision of neutron stars. These cataclysmic moments unleash energy on an almost incomprehensible scale, creating bursts that can travel billions of light years across the universe. But even as we marvel at their brilliance, we're also reminded of their potential to disrupt. A gamma-ray burst pointed in our direction could strip away Earth's ozone layer, leaving our planet vulnerable to harmful solar radiation. It's this duality that makes them so compelling. They're both a testament to the universe's grandeur and a stark warning of its power. In a way, gamma-ray bursts are like cosmic fireflies, dazzling to watch from afar, but dangerous if they get too close. They challenge us to appreciate the universe not just for its beauty, but also for its inherent risks. They remind us that exploration comes with consequences, and that even the most awe-inspiring phenomena carry an edge of danger. It's a lesson in humility, really a reminder that we're part of something far greater and far more unpredictable than we often realize. So, the next time you gaze up at the night sky, think about the gamma-ray bursts silently flashing across the cosmos. They're not just distant explosions, they're symbols of the universe's intricate balance where beauty and danger exist side by side, shaping the story of the cosmos and our place within it. Gamma-ray bursts are more than just distant cosmic explosions, they're humbling reminders of our place in the universe. These colossal events, some of the most energetic phenomena ever observed, force us to confront the sheer scale of existence. Just think about it. In the span of a few seconds, a single gamma-ray burst can release more energy than our sun will emit in its entire lifetime. And yet, here we are, on a tiny blue dot orbiting an average star, observing these cataclysmic events from billions of light years away. This perspective is both awe-inspiring and grounding. It challenges us to rethink our priorities and our understanding of what it means to exist in such a vast, unpredictable cosmos. While we often focus on the challenges and triumphs of life on Earth, gamma-ray bursts remind us that we're part of something far greater. They highlight how fragile and fleeting our existence can be in the grand scheme of the universe. But it's not just about humility, it's also about curiosity. These bursts push us to ask bigger questions. What causes them? Could they occur closer to us? And what would that mean for life as we know it? By studying gamma-ray bursts, we're not just unraveling the mysteries of distant stars, we're also learning more about the forces that shape the universe itself. They're cosmic messengers carrying secrets about the birth and death of stars, the formation of black holes, and the very fabric of space-time. At the same time, gamma-ray bursts serve as a call to action. They remind us that humanity's future may one day depend on our ability to understand and adapt to the universe's unpredictable nature. Whether it's developing technologies to detect and study these events or exploring ways to protect ourselves from their potential dangers, they challenge us to look beyond our immediate concerns and think on a cosmic scale. So, while gamma-ray bursts might seem like distant, abstract phenomena, they hold a profound lesson for all of us. They invite us to marvel at the universe's grandeur, to embrace our curiosity, and to recognize that our journey of discovery is just beginning. In a cosmos filled with wonders and dangers alike, they remind us that we're both insignificant and extraordinary, a small part of a much larger story that's still being written. Gamma-ray bursts stand as one of the most awe-inspiring and unsettling phenomena in the cosmos. These fleeting yet colossal explosions, capable of releasing more energy in seconds than our Sun will in its entire lifetime, serve as a stark reminder of the universe's raw power. But beyond their sheer magnitude, they also highlight something deeply profound: the fragility of life on Earth. In the face of such cosmic threats, our understanding of gamma-ray bursts isn't just about unraveling the mysteries of the universe, it's about safeguarding our future. By studying these bursts, scientists are piecing together clues about the origins of the universe, from the collapse of massive stars to the collisions of neutron stars. Each discovery brings us closer to understanding the forces that shape our reality. Yet, this research also has a practical side. Knowing how gamma-ray bursts work and monitoring their potential impacts could one day help us prepare for or even prevent catastrophic consequences for life on our planet. As we gaze into the vastness of space, it's easy to feel small in the face of such immense power. But this perspective can also inspire us to act. Protecting Earth and advancing our knowledge go hand in hand. Every step we take in exploring the cosmos not only deepens our understanding, but also strengthens our ability to face the challenges that may come our way. The universe is a place of endless wonder and danger, and gamma-ray bursts are a testament to that duality. They remind us to stay curious, vigilant, and united in our quest for knowledge. If you've enjoyed this journey through the mysteries of gamma-ray bursts, consider sharing this video with fellow space enthusiasts and subscribing for more explorations into the cosmos. There's so much more to uncover, and together we can continue to unlock the secrets of the universe.